Hi everyone, this is Dr.R.Alarmelu Mangai, Assistant Professor, Department of Computer Science, Dr. SNS Rajalakshmi College of Arts and Science, Coimbatore. In this video, we are going to discuss about Ardens method. So, as we have seen in the last video, we know that conversion of finite automata to regular expression, we have got two popular methods. What are those methods? They are nothing but state elimination method and Ardens method. So the state elimination method we have seen in the previous video, and now we are going to discuss about Ardens method. So coming to the Ardens theorem, it is stated that let P and Q be two regular expressions over sigma. So what is the sigma? It is an alphabet. So if P does not contain a null string, then R equal to Q plus RP has a unique solution. R is equal to QP star. So according to Arden's theorem, R is equal to Q plus RP means then you can rewrite R as QP star. Now what are the conditions to be followed here is the transition diagram must not contain any epsilon transitions and there must be only single initial state. Now what are the steps to be followed is form a equation for each state considering the transactions which comes towards that state and add epsilon in the equation of the initial state. Bring final state in the form R equal to Q plus RP to get the required regular expression. Now we will see an example. So we have two states A and B where A is the initial state and B is the final state. By taking 0, A is transited to B, and by taking 1, B has been transformed to A, the next state. So here we have to form the expressions for both the states A and B. So now by seeing this incoming edges, we are going to form the equation. So A is equal to, since it is an starting state, epsilon plus B, by taking 1 it is going to A. So B dot 1. Then B is equal to A dot 0. Now what happens? B is equal to epsilon plus B dot 0. Here what we have done in this one is by using 1 and B. So you have to substitute A in the final state, which is B. So B is equal to A.0. So what is A here? Epsilon plus B dot 1. So that has been used in this equation 2. So B is equal to epsilon plus B dot 1, and you have one more 0 in B, A dot 0, no? So that 0 has been brought over there. Then now what happens? You are bringing that 0 inside the bracket. So B is equal to epsilon dot 0 plus B dot 1 dot 0. This B dot 1 dot 0 can be rewritten as B dot within the bracket 1 dot 0. And now epsilon is epsilon into 0. Anything with epsilon you will get what? The same one. So epsilon has got no value. So B is equal to 0 plus B of 1 dot 0. Now using the Arden's theorem, we know that if R is equal to Q plus RP, then R is equal to QP star. So now Q is 0 and what is P? 1.0. What is R? B. So now we have replaced, that is used as Arden's theorem, and we have rewritten the equation 3 as B is equal to 0.1.0 the whole star. Okay. So the regular expression for this given example is 0 of 10 whole star. So as we have seen, the difference between the state elimination method and Arden's method is, in state elimination how we are getting this regular expression, you are eliminating the states, but here what you are doing, you are forming equations for each and every state, and you have to follow the condition that your state diagram should not have any epsilon. So now by using this Arden's theorem, we have formed the regular expression, that is we have converted the DFA into regular expression. Thank you. And before that, your assessment part, you have to study the Arden's method. You have to solve the problems to convert finite automata into regular expression using this Arden's method. And here we have used this reference page, and in the next session we are going to discuss about grammars. Thank you.